Here we have an integral with a rational integrand, and the denominator is factored. So we're going to use the method of partial fractions, and we're going to break up this denominator, or break up the integrand. All right, so we're going to have one fraction with x minus 2 squared in the denominator, and another one with x minus 2. And then one with x minus 5. And we just put constants on top of each. That's because these are linear. Alright, let's multiply both sides by this denominator. Okay, we're going to multiply both sides by the denominator. So on the left we have 1, and on the right we have a times x minus 5 plus b times x minus 2 times x minus 5 plus c times x minus 2 squared. All right, now we use the method of substituting in various numbers to simplify this expression and to solve for a, b, and c. So we can substitute in whatever we want for x. So let's say if we substitute in x equal 5, for example, then this will be 0 and this will be 0. And we get 1 is equal to c times 5 minus 2 is 3, squared is 9, so that means that c is equal to 1/9. All right, let's substitute in x equal 2, so that this is 0 and this is 0, and we have 1 is equal to a times minus 3. So that means that a is equal to minus 1/3. And then we can choose anything at all. In order to solve for b, we can substitute in any number at all. So let's say we substitute in x equals 4. All right, I chose 4 because it's close to 5 and it's close to 2. It's in between 5 and 2. All right, so let's do that. So we have 1 is equal to a times 4 minus 5, that's minus 1. And then we have b. 4 minus 2 is 2. 4 minus 5 is minus 1. Plus c. 4 minus 2 is 2 squared is 4. All right, now we know what a and c are, so let's write that. So we have 1 is equal to a is minus 1/3. So here we have minus 1/3 times minus 1, so that's 1/3. Okay, here we have minus 2b, and c is 1/9, so we have plus 4/9. All right, so we can just solve for b. So I'll put 2b on the other side, so I add 2b to both sides. So I have 2b is equal to 1/3 plus 4/9 minus 1. Just subtract that 1 from both sides. All right, common denominator of 9. So here we have 3/9 plus 4/9 minus 9/9. So that's equal to 7/9 minus 9/9. That's minus 2/9. Divide both sides by 2, and we have b is equal to minus 1/9. Okay, so we have a, b, and c. And let's remember where we put a, b, and c. A is on top of x minus 2 squared, b is on top of x minus 2, and c is on top of x minus 5. All right, so let's rewrite our integral. So now our integral is equal to okay, a is minus 1/3. I'll put that on the outside. Or maybe I'll just put it right here. Minus 1/3, that's a. And we have x minus 2 squared. Okay, b is minus 1/9. And I have that over x minus 2. And c is 1/9. And we have that over x minus 5. These last two integrals are log integrals, and the first one we're just going to use a power rule. All right, so let's do that. So we have minus 1/3. This is x minus 2 to the minus 2. So just add 1. We have x minus 2 to the minus 1 and divide by minus 1. And here we have minus 1/9 ln x minus 2 plus 1/9 ln x minus 5 plus c. In number 8, we have another partial fractions integral. Let's start by factoring the denominator. Okay, that's x times x squared plus 4. All right, now let's write this as the sum of two fractions. We have a over x, and x squared plus 4 is quadratic, so we put bx plus c on top of x squared plus 4. Now multiply both sides by this denominator. So we have 1 is equal to a times x squared plus 4 plus bx plus c times x. All right, and just multiply that out. We have ax squared plus 4a plus bx squared plus cx. Okay, now we're going to match coefficients. That's the method that we're going to use here. So first we'll match x squared coefficients. We have 0 on the left. On the right we have a plus b. So that means that b is equal to minus a. All right, let's go to the x coefficients. On the left again 0. On the right we have x. We have c. So c is equal to 0, and now the constant. On the left 0. On the left 1. Let me write that. On the left we have 1. That's a constant. On the right we have 4a, just 4a. So we have a is equal to 1/4. And that means that b is equal to minus 1/4. So we have a, b, and c right here. And we can rewrite our integral. All right, so we have our integrals equal to a is 1/4, so we have 1/4 over x plus b is minus 1/4 and c is 0, so we just have, I'll put the minus 1/4 on the outside, minus 1/4 x All right, so let's look at these. These are both logs. The first one obviously is log x. The second one's also a log because the derivative of the denominator is 2x, and in the numerator we have an x. So we're just missing the 2, and we're going to compensate by multiplying by 1/2. Number 9 is a trig substitution. In the integrand we have something of the form square root a squared minus u squared, and the appropriate trig substitution there would be u equal a sine theta. So in our case we have 5 squared minus 3x squared. So we're going to do 3x is equal to a is 5 sine theta. Okay, or 3 dx is equal to 5 cos theta d theta. So for dx, we'll have 5/3 cos theta d theta. Okay, now we're ready to substitute. Okay, for dx, we're putting 5/3. I'll put that on the outside. cos theta d theta. If the denominator in this integral could be factored, then we would use partial fractions. But notice it can't be factored. In fact, b squared minus 4ac is negative. So even using the quadratic formula, we cannot factor this. So what we're going to do is complete the square, and we'll end up with an arctan integral. Okay, so let's do that. Let's complete the square in the denominator. So there we have x squared plus 4x, and we're going to add half of 4 squared is 4, so we're going to add 4, and then we have to subtract 4 to compensate for adding. Okay, so the first 3 terms, there's my perfect square. That's x plus 2 squared. And then add 13 plus 4 is 9. So this turns into a typical arctan type integral. All right, and let's just use our formula to integrate this, our arctan formula. So we have arctan x plus 2 over a. Here a squared is 9, a is 3. And we have 1 over a in front plus c. In number 11 we have an improper integral. What makes it improper is this limit of 3, because 3 makes the denominator 0 in the integrand. Okay, so we're going to integrate in the usual way, and we'll just replace the 3 with r, and we're going to take the limit as r goes to 3. And I'll write this integrand as x minus 3 to the minus 1/2. And we could just integrate using the power rule. So let's do that. No constant's going to come out, because if we were to put u equal to x minus 3, du is equal to dx. So we can just use the power rule over here. All right, so let's do that. So we have x minus 3 minus 1/2 plus 2 over 2 is 1/2. Divide by 1/2, or multiply by 2. And we'll take the limit, we'll substitute in 5 and r. Let's do that. So here we have 2, 5 minus 3 to the 1/2 minus 2 r minus 3 to the 1/2. When we take the limit as r goes to 3, this goes to 0. So this limit is equal to this first term, 2 times 2 to the 1/2. That's 2 square root 2.